Hey everyone, and welcome back to the channel. Before we begin here today, please make sure that you like and subscribe to the channel because it really does help us out. And it also really does help reach others in need of assistance with these topics. So what we're going to be going over today is geometry. And we're going to be going over must-known terms, phrases, or definitions that are commonly used throughout the topic of geometry. So this is going to be one of the longer videos, a longer explanation video. No real problems here, but just going over the common terms, phrases, and definitions used throughout geometry, just so that you're not lost when someone says a certain type of angle or a certain type of word or phrase. So what we have here is we're going to have our first one up, which is a right angle. Now, some of these you may heard of. Some of these are probably new to some people. So we're just going to go over every single one as if you've never heard them before. So right angle is our first one. So a right angle is any angle that measures to be exactly 90 degrees. And this is only formed when two perpendicular lines intersect. So perpendicular, that word right there just means that two lines form 90 degrees when they cross one another or they intersect one another. So right here we have line AB and BC. These two are perpendicular lines because when they intersect at point B, they form a 90-degree angle, or what is commonly shown as a little box in the corner there. Usually angles will be shown with some kind of arc, but a 90-degree angle will always be shown with a little rectangle symbolizing perpendicular lines are meeting there. So another way you would probably see the perpendicular lines being intersect in a form, a written out form instead of a picture form, is using this symbol right here, this upside down T symbol. So if you wanted to say that these two lines are perpendicular in written form, what you would write would be AB, this little upside down T, and then BC, meaning that AB, when intersected with line BC, makes a perpendicular 90-degree angle. All right, so moving on here. Next term is straight angle, which is kind of funny because a straight angle is literally just a straight line, and it measures to be exactly 180 degrees. So what this means is that this angle right here from this side to this side between AB and BC is 180 degrees. Every straight line, if it is a truly straight line between two segments being put together, measures out to be 180 degrees. And that is a very important piece of knowledge to know when you're working with geometry. So a way that you could write this here is commonly seen in geometry is that we will write this little angle symbol and we will write 3 letters after it, denoting what the angle is here. So this little symbol means angle of this segment. So the center letter inside your segment statement will always be where the angle is being measured from, or about that point. So what this is saying is that the angle of line ABC, well, the angle is going to be right where B is, and if you were to finish this out for a straight line, would be equal to 180 degrees. So you would probably see this type of statement a lot, not with exactly 180 degrees, but referring to any type of line or angle. So if we were to express that just like with the 90-degree angle, which you commonly wouldn't do that with a 90-degree angle, but if you wanted to, you could write it like this. Angle ABC is equal to 90 degrees if you wanted to write it like that. So those are 2 very important ones, and they really do help out when you're working with harder geometry problems. So moving on to our second page of terms here, we have an acute angle. An acute angle is any angle that is smaller than 90 degrees or smaller than a right angle, which a right angle is 90 degrees. So you would have an angle of a line segment, for instance, that would look something like this, where this angle right here is less than 90 degrees. So this angle, for instance, it could be like this could be 2 degrees, or it could be 89 degrees, or it could be 1 degree, or it could be a very small angle of 0.01 degree. Anything between 0 and pretty much 90 degrees would be an acute angle. And then conversely, an obtuse angle is just the opposite of that, where an obtuse angle is any angle that is larger than 90 degrees or larger than the right angle. So it would look something perhaps like this, where this angle is larger than 90 degrees, like it could be 110 degrees, or it could be 179 degrees. And these angles can be in any form here as long as they're between 90 and 180. Typically, the true definition of obtuse, if you want to write out the true definition of an obtuse angle, it's anywhere between 90 and 180. Some people just go ahead and say anything larger than 90, but technically we have another term if you're larger than 180 degrees, and that's called a reflex angle. So a reflex angle is any angle that's larger than 180 degrees. So for instance, if we had something that looked like this, where this portion's an acute, well, if we wanted to measure this angle going all the way around, well, that would be larger than 180 degrees because, well, how much do we have in a circle? We have 360 degrees total in a circle. And if we have less than 90 right here to go all the way around, it's definitely going to be greater than 180 degrees. So technically, a reflex angle is the better definition for anything larger than 180 degrees. All right, our third page. So this is where we have some different pronunciations that can happen. You can either call these complements or complementary or complementary angles. Goes by a couple different pronunciations there. But whenever you see this one or this one, what that means is there's two angles being added up to be 90 degrees or to form a right angle. So looking at this diagram right here, when we have this segment, because this is made up of two segments, like such, where this was ABD, and this is DBC. So let's say that these two are smack together at point B, and let's say this angle for the first one was 30 degrees, and this one for the second one is 60 degrees. Well, when you put these two angles together, what is 30 plus 60? It's 90. So any addition of two angles being put together that makes 90 degrees will be this type of angle formation, a complementary. So if you wanted to write this out in true form, you would say the angle of ABD plus the angle that occurs at DBC would be equal to 90 degrees. Another very important definition and term there. So that was 90 degrees, and just like where we had acute less than 90, well, we're going to have something where it equals 180. And once again, different ways to pronounce this, just depends on who you're talking to. Supplements, supplementary, or supplementary angles. And this is just two angles adding up to be 180 degrees, or two angles that form a straight line. So once again, we have this first one of EFH, and then a second one of HFG. These two angles, when added up, would be equal to 180 degrees. So for instance, since this is an obtuse angle, it has to be larger than 90 degrees. So let's just make it easy math, and let's make it 110 degrees. And then this one is an acute, which means it's less than 90 degrees. So 70 degrees, and when you add those two up, you get 180 degrees. Another very important type of definition there that is commonly used throughout the world of geometry. And then we have adjacent angles. So before I go on to adjacent angles, let me just, an easier way to go back a little bit, easier way to remember the definitions between a complementary and a supplementary angle is this. So supplementary, or supplementary, however you want to pronounce it, begins with the letter S. And a straight line, that whole thing begins with a letter S. So that's one way to remember it, because a straight line is 180 degrees, And a supplementary angle forms 180 degrees when you add those two angles together. So that's one way to remember that supplementary is 180 degrees with a straight line, and the opposite complementary is 90 degrees. Nice little easy way to remember it right there. S equals S. So straight angle or adjacent angles, sorry. Adjacent angles are ones that are beside each other. And just looking at this above picture right here that we use for supplementary, where we have these two angles of EFH and HFG, we would say that these two angles are adjacent because, well, they're right next to each other. So you could write it like this, where you have EFH and angle HFG. Keep in mind that center term or that center letter is where the angle is actually occurring, are adjacent. Basically, anytime you see the word adjacent, that just means directly next to. Alrighty. So on to our next page. A little bit of an easier page here. So a full circle, kind of mentioned it earlier, a full circle, whenever you have a circle, that just means that you're going to have 360 degrees total, because it takes 360 degrees to go all the way around. So what this means is that you just have a total amount of angles that are adding up to 360 degrees. You have a complete circle going on. And it could form as many angles as needed to get there. You just need a minimum of at least two, because a current one angle at 360 degrees, we really don't say anything about it. We just say it's a circle. So we have two pictures here where we have 3 angles on this one and then 4 angles on this one. Well, knowing that there's 360 degrees in a circle, we could write it like this, where we have angle A plus angle B plus angle C is 360 degrees. And if we knew a couple of those angles, we could find the very last one using this property. And then similarly over here, we have the same thing. We could say W plus X plus Y plus Z gives us 360 degrees. Oh, and just a note, if you watch any of my future videos where we have the letter Z, that is how you write an engineering Z, because a lot of people will write 2 like that. I write 2 like that, and I write Z like that, just to differentiate between the two of them. So that is how I write the letter Z. So what that just shows you is that when you have angles all the way around, they total up to 360 degrees. That way you can find some of the angles if a few are missing. So using this picture right here, it will help us with our next definition, which are vertical angles. These are angles that are equal and appear on opposite sides where 2 lines intersect. So sometimes vertical angles are called opposite angles. Even though they're not technically opposite, they're equal to one another. So that's why we usually call them vertical angles, but you may hear them called the opposite angles, even though they are equal in value. So what this means is that from whenever you have a picture like this with 2 lines intersecting, the angles that are in the opposite portions will be equal to one another. So let me switch colors here. So what that means is that the X and the Y are opposite each other, so they are equal in value. And the same thing for the Z and W. They are opposite each other, so they are equal in value. So angle X and angle Y will be equal to one another, and angle W and angle Z will be equal to one another. Each one of those sets are called vertical angles. So X and Y, vertical angles with each other. W and Z, vertical angles with each other. Can't tell you how many times this pops up in geometry, trigonometry, engineering, knowing this property here. Alrighty. So moving on to the next set of terms here, we have congruent, which just means that 2 or more different line segments of the same length. So we have 3 pictures here of a line segment, which is just a fancy way for saying a line, that they're all 8 feet in length. Doesn't really matter which or what the orientation is, as long as it's the same length, they're considered to be congruent. So as you can see, we have one that is completely horizontal and flat, one that's at an angle, and then one that is completely vertical. These are considered to be congruent with one another. And then along that same term, we have what's called congruency. So this is when we have two geometric figures that are identical, or a simple way of saying two figures that are not lines that are equal to one another. And the same type of idea here, let's say we got a little square here of 8 inches by 8 inches, and then the next one is just rotated a little bit. It's still 8 inches by 8 inches of a square. So they have congruency, which means they are pretty much the same shape, just at different orientations or rotations. And typically when we have this happening, we don't just write the equal sign, we write the equal sign with a little squiggly above it, which you may see it written like that or written like that. But typically writing it something like that means congruency, or approximately the same, because you also see that in math written as approximately. But in geometry, it's written as congruency. Yep, I thought we had one more on this page. So bisect is our last one for this page. And bisect, the definition of this is if a line segment or an angle is bisected, this means that it is cut into two congruent or equal parts. So for instance, before we had a bisector line here, we had this angle right here of DGF. And then we had this E come in and just slap right in there at point G. So GE is considered to be the bisector of this angle. And whenever you have a bisecting line, if it is a true bisecting line by definition, these angles will be equal to one another that result from that bisection. Alrighty, to the next page. We only have 2 more pages to go, including this one. So collinear. Collinear is when you have 3 or more points that lie on the same straight line. Kind of gives it away in the name. Linear means straight line. And collinear just means you have multiple points along a straight line, kind of like playing connect the dots, but with a straight line. So if points A, B, and C are truly collinear, that means they lie on the same straight line, meaning that I don't have to make a curve to get to B or to get to C. I can just go wah with a straight line through all the points and play connect the dots. Whenever that happens, those points that you are connecting are considered to be collinear. So that just also helps us realize straight lines are 180 degrees when we're looking at certain objects. Concurrent, or some people say concurrent. Either way, once again, just depends upon how you pronounce things. So this is when we have 3 or more lines that intersect at the same point. So we have 3 lines here of DI, EH, and FG, and they're all intersecting here at the center point. These 3 lines are considered to be concurrent since they are all smacking in at the same point. Now, we had something that looked like this. You see how there's like a little gap right there, or maybe I should make it a little bit bigger. Hang on. Unless your TV is really huge, you probably won't be able to see that. Let's make it look something like that. Well, these 2 lines intersect at the same point, but this third one, nah, it's a little bit off. So this right here is not concurrent. This on the left side is concurrent. Parallel. Kind of like the opposite of perpendicular, you will pretty much hear parallel and perpendicular used a lot, especially when you're looking at XY coordinate systems. But in geometry, what we're looking at here is parallel lines. These are lines that extend in the same direction forever and ever and ever, and they will never cross each other. They will remain the same distance apart. They will never intersect each other. They will never get further away from one another. They will never get closer to one another. So we have 2 examples here of these 2 arrows running in the horizontal direction from left to right, and the distance between them will always be the same, no matter what. And then another set over here running vertically. Once again, that distance between them will be exactly the same, no matter where they are. And of course, they don't have to be strictly horizontal or vertical. You can have parallel lines at any angle as long as they remain the same distance apart, never moving closer or further away. And an example to think of in real life of this is railroad tracks. Now, technically, those railroad tracks that the trains run on will get a little bit closer, a little bit farther away from when they're on curves. But think about the straightaways. If you had a train track or the rails going closer and further away from each other, that's going to be a really, really bumpy ride for that train. You don't want the rails to increase or decrease in distance from one another because you want that smooth ride. So that's a good way to think of what parallel lines actually are in a real life scenario. All right, our last page here, which may be one of the most important ones, depends upon how you think. So transversal or transversal lines. So transversal is when a line that intersects at least two other parallel lines. Now, there are definitions out there that say transversal lines are also lines that just intersect two other lines. Technically, yes. But to be honest, it's quite useless if they're not parallel. In real life situations, when they are parallel, there's a lot of use you can get out of it. A lot of use out of that transversal line when it's intersecting two parallel lines. So this picture shown here on the screen, we have parallel lines where we have AB is parallel to CD. And then we have our transversal line of EF going through those two. And then we have 8 angles representing here. Now, these 8 angles are going to be very important because there are a lot of properties involving transversal line through parallel lines. So looking at this figure above, we're going to look at different definitions here and determine what's going on here. And this will be extremely useful in real life applications. So interior and exterior angles. These are angles created by the transversal line, which, duh, right? But what are they? Where are they? So interior, we'll mark those in red. So interior angles are the angles that are between the two parallel lines. So interior angles would be 3, 4, 5, 6, because they are inside the parallel lines. So you would have 3, 4, 5, and 6 would be your interior angles. And I'm betting you're probably wondering what the exterior angles are. Well, they're just the angles beyond the parallel lines that form. So 1 and 2 and 7 or 8 are beyond. They're not in between the lines. They're beyond the lines. So the exterior angles formed here would be 1, 2, 7, and 8. So you may commonly hear them as interior angles or exterior angles, and that's what they're referring to, are those types of angles right there. Just a lot of nomenclature and definitions and terms being thrown around in geometry, and it's best to know exactly what is being discussed. Corresponding angles. This is where we start getting into what is actually going on here. So corresponding angles. These are equal angles created by the transversal line. There is a bunch of equal angles here. So corresponding angles. So if you look at this picture up here of the AB intersecting by the transversal line, this picture right here, doesn't it look very, very similar to this one right here? If you remove the numbers and you just copied and paste that down there, wouldn't those angles be right on top of one another, be exactly the same picture if you just replace the numbers? Well, yeah, because the lines are parallel, they are going in the same direction. This transversal line is going in the same direction, so the same angles will form. So what this means is that angles 1 and 5 are corresponding and they are equal. So you could rewrite this as 1 is equal to 5. 2 is equal to 6 because it's in this upper right corner of the line. So 2 is equal to 6. 3 in the bottom left is equal to 7 in the bottom left. And then in the bottom right, you have 4, which is equal to 8 in the bottom right. So that really helps out because if you're trying to determine what angles are here, if you know what 4 is, boom, you know what 8 is. If you know what 1 is, boom, you know what 5 is. So it really does help out knowing those corresponding angles. But there's more with this transversal line here. And we're going to scroll down a little bit because I have the same picture here at the bottom. So last two things here. Alternate interior and alternate exterior angles. These are once again the angles created by the transversal line, but which ones are they exactly? So alternate interior angles. These are angles that are equal, but on opposite sides of the transversal line. That's what alternate means. So the definition of alternate is equal, but on opposite sides of the transversal line. So you're either on the left side or you're on the right side. Interior and exterior still mean the same definitions as before. Interior means you're in between. Exterior means you're beyond the parallel lines. So putting those two definitions together for alternate meaning equal, but on either the left and then one on the right of the line. So alternate interior, which I'm just going to write as AI. Well, 3 is on the left side. It's an interior. It will be equal to 6, which is on the right side of the transversal line and still an interior. So this means that 3 is equal to 6. And you can kind of see that right here. And then the opposite in alternate interior is 4 is equal to 5. Once again, 1 on the left side is equal to the other one on the right side. 5 is not equal to 6 because look at the difference in angles here. 5 is equal to 4. 3, once again, is not equal to 4. It's not equal to 5. It is equal to 6. And here's a little bit of more of an explanation there. So alternate interior angles and exterior angles means that the angle has to be equal internal, and on the opposite side it is. So number 3 is on the left side. It has to be equal to one of the other 4, or one of the other 3, 4, 5, or 6. Internal means it's not 1, 2, 7, 8. Internal means 4, 5, or 6. Alternate means it has to be on the opposite side. Well, 3 is on the left side of the transversal line. The right side means it has to be over there. Its equal counterpart has to be over there somewhere. Well, it can't be 4 because look, 3 is much larger or much smaller than 4. It has to be 6. So then, just looking at the same reasoning behind exterior, alternate exterior angles. What this means is that 1, well, it can't be 2. 7's still on the left side. It has to be 8. So 1 is equal to 8. And then if we look at 2, well, 2's on the right side. Can't be equal to 8. Can't be equal to 1 because those two make up 180. They can't be the same. It's got to be 7. So looking at alternate interior and exterior angles definitions, what's equal to what, and what we found earlier with corresponding angles. So 1 is equal to 8, which is equal to 5. Well, what is 8 also equal to? 8 is equal to 4. Well, 4 is equal to 5. So there's a lot of equal angles here. So what this means is that 1 is equal to 4, is equal to angle 5, is equal to angle 8. They're all the same. And then looking at the second line here, or the second possibilities for angle 2, 2 is equal to 6 and equal to 7. Well, 7's equal to 3, which 3 is also equal to 6. So you could have angle 2, which is equal to angle 3, which is equal to angle 6, which is equal to angle 7. So looking at what we have here, get off that. There we go. So angles that will be marked in blue, or actually they are blue, so let's mark it in a different color. Let's go green. So angles marked in green are going to be equal to one another. And let's mark angles. Let's just circle it with black. Angles marked with black here are going to be equal to one another. And you can kind of see what's going on here because this snapshot, just like what we did earlier, It's just a copied version of this bottom one right here. They're exactly the same because of parallel lines. So 1 is equal to 4, 2 is equal to 3. They're opposites, just like what we were talking about earlier. They're opposite angles. And then, since they're copied and pasted and parallel lines, well, look, 5 and 6 are equal, and 7 and 6 are equal. So it really does work out using transversal lines. It makes life a lot easier. And I said that these were opposite angles. Well, remember, you can call them vertical angles as well. Same thing. But that's what really happens when you have parallel lines with a transversal line. You get a lot of, well, a lot of angles being equal to one another. And it makes things much easier to solve if you know this definition here. So this was more of a longer video, but I hope it was helpful in explaining some of these commonly used terms and phrases in geometry. We're going to be posting more geometry videos here on the channel, so please check those out. Also, if you haven't done so already, please make sure you like this video, leave a positive comment below, and subscribe to the channel because it really does help us out. Thank you for watching, and I hope you have a fantastic day.